So we've surfed through this before. This is exactly what we've had in the past. This is the distribution for the number of other friends a node has. But now we're thinking about if we travel along an edge in this affiliation graph and we hit, right, so we're going down, and I don't know if I put tropes at the top, but if we hit a story, how many we're traveling from a trope to a story, how many other tropes does it have? That's this piece. And then this is the opposite, right? So we're traveling to a trope from a story. How many other stories does it have? So these two pieces, we can put them together, right? We're going to need to have this one and this one. And really what you want is the average of this and the average of this, right? The average number of other stories and the average number of other tropes that a trope and a story have, I think I got that right, respectively, multiply together to be greater than 1. And then you'll have maybe I didn't say this clearly, then you'll have a giant component. You'll have a big connected structure. Right? And this is just structure, but of course a few steps away from that is contagion. Does this thing spread? Do we have a network where we say, with some probability each edge is conducting, or there was a disease spread or an idea spread? We can play around with the structure. But once we need to have this underlying story first. Okay, so I changed this notation. Not everywhere. That's disappointing. So these ones should be bipartite. I'll fix that up. Okay, this is the weeping less part. So I'm going to call them these probabilities of bipartite things, and these are the induced ones. These are the dish for these probabilities, right? I'm going to have two labels, but this is going to be within this network. If I choose this one and then look at its, I go to this story and then I find how many other stories it's connected to through tropes. What's the probability that it's connected to k other stories, right? So that's just within that bipartite thing, and this is going to be the same as what we'll call the induced one, which is if we actually just made links, right? So if you have stories that share a trope, we just put a link between them. But I will also just sort of use this notation that within the bipartite network, it's sort of like a two-step aspect of the system, and these should be bipartite as well, right? So these should be BIP, BIP, and this is, so I probably should show it here, right? So this is, these are the things we're talking about, right? So this is for stories on the bottom, right? This one has actually 1, 2, 3 other friends that it's really connected to because they share tropes. And then this one here, this is a trope. It has these two stories that it's part of, and that connects it back up to actually 1, 2, 3, 4 other tropes. And in fact, this is a situation, it may not be obvious, but this is, you imagine this keeps going out and out, right? So all of these have 3 friends, all of these have 3 friends, 3, right? So these are actually a very simple degree distributions here, right? So that's what it is, delta K3, Chronica delta. And all of the movies have 3 stories in them. All the stories have 3 tropes in them, and every trope is part of 2 movies. 2 stories. And then we're just randomly wiring them up, right? So this could be a way to write your screenplay, right? So you're going to have, every screenplay you write is going to have, there's a big box of tropes, and you're just going to choose 3 of them and put them in there, right? Boy meets girl, turns into chicken, whatever, right? And you could probably do pretty well, actually. So, and then from that, actually, so we should be able to figure out, and we can, that this means that, right, these ones have 2 friends, these ones have 3 friends within this bipartite thing. That actually, you can deduce that these ones will all have 3 friends in their induced version. These ones will all have 4 friends, right? So we should be able to figure that out. So that's a little doable calculation. Okay, and that's just to show what this is. Again, yes, right? So this one has 4 friends, and good. So the more complicated one, and this is where my notation really went got into trouble because induced was okay for probability, but this is R, right? And we're going to call this bipartite. So the idea is now we're staying within the bipartite network. We're going to take one edge, one story trope edge. We're going to travel up that, travel back down to any stories that that's connected to, right? So this could go to many, but in this case it just goes to one, and then go back up to all of the tropes. So you want to take an edge of this type, one going from story to trope, and see how many new ones it makes. So it's usually right about edges. We have an edge that begets 7 new infected edges. Here's an infected edge, or just an edge leads to 7 new ones. This is now a more complicated type of edge. It's an edge that starts at a story, ends at a trope. So we follow that through, then we have to bounce down once, and we'll get, this is our new one, and this is a new one. So this edge led to 2 new ones of the same flavor. And up here, we've got a trope to story edge, so we're going to run down that one, and then go back up to anything that's above it. And so there are 2 tropes, then follow down from them. So this one leads to these 2, same thing. So we should be able to figure that out. And again, this is a case where, so this one has is always 2 actually, right? So it's a Kronecker delta K2. Right, so the number of new edges that this always begets is 2, right? So this one made 2, and same here, this one made 2. And we should be able to derive that from the fact that underneath this we have a degree 3 distribution here. Everyone has 3 friends, and everyone has 2 friends up here. But the key thing then will be putting these pieces together, right? Because we'll need to know, if we go up this edge and we go down this kind of edge, and then back up again, do we start to connect to more than one of the same kind? Is this a, it's our fundamental question about networks, is there a giant component? One of our fundamental questions. I mean, if there's not much can happen on it that's super interesting.